Welcome to the Calculus B section. In this section we'll be discussing arc length. Now, here we have the definition of arc length. L is equal to the limit as n approaches infinity, sigma ni equals 1 for pi minus 1 times pi. So as you can see to the right of the definition, there is a depiction. We're going to say that this is the y-axis and this is the x-axis. There's a depiction of a function. So in the event that we wanted to find the arc length of the function, our most accurate representation to what we know as of now is by saying that we can take tangents of each segment of the function to figure out the length of the curve. As you can see, there are going to be some points of error here, there's going to be error here, error all around here. But if we were to get these lines so small, for example, if we were to just trace it ever so small across every single point of this curve, we would have a pretty accurate arc length. And that's essentially what this limit to n infinity does. So let's get to discussing what pi minus 1 times pi is equal to. So over here on the right of our illustration, we know that pi minus 1 is equal to xi minus 1 squared plus yi minus 1 squared. And this is because we have our graph on the xy section, and we know that p1 is just a curve along our curve, which means that there is definitely going to be an x coordinate and a y coordinate. All we're doing is subtracting this coordinate here. Let me make that more visible. Subtracting this coordinate here from the endpoint of this coordinate here to find the slope of our p1, and that's going to give us pi minus 1 times our pi, which is going to be given by yi minus 1. Okay, now that that's out of the way, we know that we can simplify this to actually the change in x squared plus the f prime of xi squared times change in x squared, which simplifies to the square root of 1 plus f prime xi squared times change in x, which is outside of the square root. Now, if that doesn't look familiar, we can also rewrite that formula to equal the square root of 1 plus dy dx squared times dx. Now, if we were to plug back our pi minus 1 times pi back into this equation, we can actually state that the L is equal to the integral from the square root of 1 plus dy dx squared dx. This is because essentially when we state that we want to find the sum of all the numbers from n infinity, very small, essentially very small intervals, we are essentially saying that we want to take the integral of this region. So that means that our arc length formula is going to equal the integral from the square root of 1 plus dy dx squared dx when we're dealing with x, and it's also going to equal the integral square root 1 plus dx dy squared with respect to y. So that is how we compute arc length, and it does make a lot of sense because we want to find infinitely small tangent points to or lines to our curve in order to find the length. I hope that helps. There's a bunch of problems on the website, and if you need extra assistance, there is that as well. I hope that helps.